Now let's discuss about Chapter 10, Simple Linear Regression and Correlation. Under this chapter, we have the subtopic of Empirical Model. An empirical model is based only on the data and is used to predict, not explain a system. An empirical model consists of a function that captures the trend of the data. The graph of the function goes through the data points approximately. The least square method is a statistical procedure to find the best fit for a set of data points by minimizing the sum of the offsets or residual of points from the plotted curve. For example, we have the data of the age will be our x 43, 48, 56, 61, and 67, and lastly 70. And their pressure is will be Ry, which are 128, 120, 135, 148, 141, and 152. And let's have a chart to illustrate this data. Naayon dito sa chart na ito, pinapakita na mas mataas ang pressure ng age 48 kaysa sa 43. At bigla siyang tumaas no sa age of 56 at 61 at bumaba ulit siya ng 67 at lastly tumaas siya sa huli. Now let's proceed. Linear regression. Linear regression is the simplest and commonly used statistical measure for prediction studies. It is concerned with finding an equation that uses the known values of one or more variables called the independent or predictor variables to estimate the unknown values of quantitative variable called the dependent or criterion. It is the prediction when a variable y is dependent on the second variable x based on the regression equation of a given data. After a scattered plot is constructed and the value of correlation coefficient is deemed to be significant, then an equation of regression line is determined. The regression line is the data's line to be fit. The closer the points fit the regression line, the higher the absolute value of regression, and the closer it will be to +1 or to -1. Now let's take a look for the formula for regression line. Y prime is equal to a plus bx. B will be equal to sum of square xy over sum of square xx, and a will be equal to x bar minus bx, where x bar mean of x, y bar minus bx bar. Sum of square xy is equal to summation of xy minus summation of x times summation of y over n. For sum of square of xx will be equal to summation of x square minus summation of x square over n. Note, round the values a and b to 3 decimal places. Before we proceed for the example, first we will have the characteristics of the regression line. When b is greater than 0, y increases as x increases. In this case, we say that y is directly or positively related to x. And let's see the relationship by using a chart. This chart shows that we have positive linear. Next. When b is less than 0, y decreases as x increases. In this case, we say that y inversely or negative related to x. Now, let's see the relation by using chart again. As this chart shown, we will have negative linear. Next. When b is equal to 0, y is constant and is equal to y intercept a. This implies that there is no change in y whatever x value is, which means that there are no relationship for this characteristic of regression line. Now, let's have an example. A statistic professor at a state university wants to see how strong the relationship is between a student's score on the test and a student's grade point average. The data obtained from the following is the test score will be our x, the GPA will be our y. Now, for our solution, we should determine the x, y, and x square and y square. Xy will be multiplied by 98 and 2.1, which will be 205.8, and it follows. And for x square, we will just 90 multiply that 98 times itself. It will be 9604, and it follows. And for y square, we just multiply by itself 2.1, and it will become 4.41, and it follows. And according to our formulated formula, first we will use this formula. Let's determine the sum of square xy. Now we all know that summation of xy is 2321.1, and our summation of x is 832, and our summation of y is 200.1, and our n is 8. And when it compute, we will have 22.7. Next formula is sum of square of xx. Now, we all know that summation of x square is 86,890 minus 8 square divided by 8. Now, our sum of square xx is equal to 362. So, we have the value of our sum of square xy and sum of square xx. Now, the values needed for the equation are these. So, next step, we should determine our x bar, which are 104, and y bar, which are 2.76. And for the next step, we will determine our b. We all know that our sum of square xy is 22.7, and sum of square xx are 362, will be equal to 0.063. And for a is equated that yx bar minus bx bar is equal to 2.76 minus times 0.063 times 104 is equal to negative 3.792. Now for the final step, we will determine the y bar, which are the formula r is equal to a plus bx, which are a is 3.792 plus 0.063x. Now let's proceed for correlation. A scatter plot is a graph of ordered pair x and y of numbers consisting of the independent variable x and the dependent variable y. The independent variable is the variable that can be controlled or manipulated. The dependent variable is the variable that cannot be controlled or manipulated. The independent is plotted on the horizontal axis and the dependent variable on the vertical axis. The purpose of this graph is to determine the nature of the relationship between the variables. The relationship may be positive linear, negative linear, curvilinear, or no discernible relationship. Correlation is the statistical method used to determine if there is a relationship between variables and the strength of the relationship. Percent correlation coefficient. The degree of linear associated over relationship between two variables, at least of interval scale, is measured by a correlation coefficient denoted by R. which are relation. It is sometimes called person correlation coefficient, which means person product moment correlation coefficient in honor of its development. For the formula for the correlation is R is equal to N summation of x y minus summation of x times summation of y over square root of n times the summation of x squared minus summation of x squared times n summation of y squared minus summation of y squared. Now let's just determine the meaning of this formula, where n is equal to number of pairs of scores. The summation of x is sum of x score. The summation of x squared is sum of squared x score. And summation of xy is sum of the product of paired score. And summation of y is equal to sum of y score. And lastly, summation of y square is equal to sum of square y score. Now let's have interpretation. If the value of r is positive or negative 1.0, the correlation will be perfect. And if positive and negative 0.82, 0.99, the correlation will be very strong. And if it 0.60 and 0.79, the correlation is strong. And so on until there are no correlation. Now let's proceed to example. This is example also the example of our first subtopic for this chapter. The computed xy is this, and x squared is this, and y squared is this. We all know that the summation of x is equal to 832 and the summation of y is equal to 22.1 and the summation of xy is equal to 2321.1 and the summation of x squared is equal to 86,890 and the summation of y squared is equal to 63.83 and our n is equal to 8. Now, let's compute this by using this formula. At ngayon, nalaman na natin na ito ang ating mga gagamitin. Ipla-plot na lang natin siya dito sa formulang ito. Ngayon na-plot na natin siya, isi-simplify na lang natin siya into a log's term, which are magiging 181.6 over square root of 2,896 times 22.23. Ngayon, mas ipapasimplihin pa natin siya para mas madali siyang computed. Times na natin yung nasa baba at ngayon makukuha na natin ang ating R which are equal to 0.72. Ngayon, dahil nakuha na natin ang ating R, which are the correlation, ngayon i-interpret na natin siya kung ano yung nangyari dito. The correlation coefficient suggests a strong positive relationship between the test score and the grade points average. Kaya kung bakit siya naging strong positive, nakikita mo siya sa interpretation natin sa table. Tulad nito, na kung nakuha natin is 0.72. Na dahil dito, under siya sa 0.60 at 0.79, kaya naging strong correlation siya. Dito natatapos para sa chapter 10.